Good afternoon, everyone in India, and good morning to everyone in Europe. Welcome to this webinar on emerging energy storage opportunities in India. Before I start the webinar, I would like to lay a few ground rules. All of you would be muted by default. This is done so that we erase any background noise that could occur. And two, there is a question and answer panel that you would see at the right bottom corner of your screen. During the presentation, feel free to post your questions, which will be answered towards the end of the presentation. We have an hour to our disposal. Let us make maximum usage of this hour. We would have around 30 to 35 minutes of presentations, followed by around a 25-minute question and answer session. So let's start today's discussion. Admin, if you could change the slide. So today, my name is Joel Fernandez, and I'm the Regional Director for the European Business and Technology Center. I am based out of the Mumbai office. Today, I have the pleasure and honor to welcome Dr. Rahul Walawalkar, who's the Vice President, Emerging Tech and Markets, Customized Energy Solutions. Rahul is also a very strong supporter of the work of EBTC. He holds a PhD in Engineering and Public Policy and an MBA from Carnegie Mellon University. Welcome, Rahul, and as one of our presenters and our guest speakers for today. Rahul is also the Executive Director for India Energy Storage Alliance and the Vice Chair for the Global Energy Storage Alliance. Just to share with you what our agenda is going to entail, I will present to you on EBTC, just 2 slides presenting to you what is EBTC and how we can help you in your India market entry strategies for India. And then I will pass it on to Rahul Walawalkar, who will talk about the emerging energy storage opportunities in India, followed by question and answers. So what is EBTC? EBTC is an EU-funded initiative that focuses on clean technology solutions. It helps businesses and researchers from Europe to find opportunities in India and Indian businesses and researchers to find opportunities in India, particularly focused on clean technology. EBTC is the only center dedicated to promoting European clean tech in India. We focus on 4 sectors: biotechnology, energy, environment, and transport. EBTC has offices in 4 locations in India: New Delhi, where we are headquartered, Bengaluru, Kolkata, and Mumbai. In Europe, we are represented through Euro Chambers, which is an association of chambers of commerce based out of Brussels. EBTC is also the nodal point for the Enterprise Europe network in India. So how can EBTC help you through our services? So EBTC is a tailored toolbox of services. Our team of 20 of us at EBTC in India are able to have different backgrounds, whether it is finance, consulting, policy, or trade. We are able to offer you customizable solutions in terms of understanding the Indian market, whether it is to find a project or partner in India, or whether to establish your organization in India. EBTC can also, through its business incubation and technology incubation platforms, help you localize your technology. Particularly for a country like India, it is extremely important to customize your your technology for the local market. We also provide funding advice. EBTC does not offer any funds as such, but through its connections, we are able to offer you funding advice in terms of raising capital in India. So these are some of our services and a very short description of EBTC. To maximize on time, I would like to now pass it on to Dr. Rahul Valavalkar, who will focus on today's discussion topic. Rahul, the floor is all yours.
Sure. Thank you very much, Joel, and thank you very much to EBTC for giving me this opportunity to share some exciting news about energy storage opportunities in India. As Joel mentioned, I am the founder and executive director of India Energy Storage Alliance, which is an initiative by Customized Energy Solutions, and also I am a vice chair of Global Energy Storage Alliance and director at Energy Storage Association in US. So to set the background, as most of you are maybe already aware, India is the largest democracy in the world with population close to 1.2 billion. But when you look at the energy infrastructure in India, India has not grown its energy infrastructure at the same pace as the developed or even other developing countries such as Brazil, Russia or China has done in last 15 or 20 years. And that's where there is a significant gap currently between supply and demand, where in India, in different parts of the country, customers, particularly commercial, industrial customers or residential customers are faced with very much scheduled load shedding activities which are used as a primary tool for balancing the grid. But with the current focus of new government, it is expected to change with rapidly within next 5 years, where the government has set very ambitious goals of making electricity available round the clock to every citizen in India. So looking at these changes and looking at the economic growth target which India has of growing somewhere between 6% to 10% year on year, if you consider the additional energy requirements of Indian grid, then India needs to add somewhere around 400 to 1,000 gigawatt of new generation capacity within next 15 years. Now currently India has a total installed base of somewhere around 220, 230 gigawatt. So you are looking at least doubling or maybe increasing it by additional 4 times within a span of next 15 years. And that is a very challenging task. It's not unprecedented. China has demonstrated ability to do that. China has added year on year somewhere around 75 to 125 gigawatt of new generation every year for more than last decade. So technically it can be achieved, but given the democratic nature in India as well as some of the challenges of fuel availability, India has realized that this is not going to happen only with centralized generation resources. That's where India is looking very aggressively at use of renewable technologies for meeting some of the challenges. Currently, India is already one of the leaders in adoption of both wind and solar. India has, as of end of last year, installed more than 20 gigawatt of wind and currently has more than 2 gigawatt of solar installed. But they are with Ministry of New and Renewable Energy at central government, they have a very aggressive plan of adding at least 50 gigawatt of additional renewable energy with 30 gigawatt of wind and 20 gigawatt of solar by 2020 on the Indian grid. And part of this will happen through distributed resources such as rooftop solar initiatives, and part will be done through centralized resources. There are some RFPs out currently where Solar Energy Corporation of India is looking at setting solar parks in every state of the country, and also there are some major plans for setting up solar farms as large as 4,000 megawatt individual capacity. So there are going to be opportunities for both distributed as well as centralized renewable resources. Now, considering these challenges in India in terms of having energy access for all the citizens, as well as meeting the power quality requirements and reliability for commercial industrial customers, while the need for accommodating more and more renewable energy into Indian grid, energy storage technologies can play a very critical role in enabling this future. Now, when we talk about energy storage technologies, lots of time people think of mainly either lead acid batteries or pumped hydro, and both are very essential part of the energy storage technology landscape, but they are sort of two extremes. If you think of other technologies which could be deployed at hundreds of megawatt, These include technologies such as compressed air energy storage, where currently there are a couple of projects with 100 megawatt plus sizes installed in both Europe, in Germany, as well as in US, in Alabama, and there are 3 or 4 projects in parallel currently getting constructed for compressed air energy storage technologies. Similarly, there are a number of electrochemical or mechanical technologies such as lithium-ion batteries, advanced lead-acid batteries, flow batteries, as well as flywheels, which are currently getting demonstrated at various sizes, starting with hundreds of kilowatt to even 20 to 50 megawatt level, which are very appropriately sized for placing in the transmission and distribution network for optimizing T&D investments. And of course, last but not the least, energy storage technology is right from kilowatt or sub-kilowatt level to tens of megawatt level could also be integrated as a behind-the-meter resources on customer premises, and then enable use of these technologies for providing greater flexibility to the grid through programs such as demand response programs, which are becoming more and more popular around the world. So looking at this, India Energy Storage Alliance did first of its kind of market assessment for assessing energy storage market potential in India at start of 2013. Currently we are in process of updating these numbers, and a new report will be released at our annual conference in first week of December. But the current assessment suggests that there is a potential for at least 15 to 20 gigawatt for advanced energy storage technologies for range of applications starting from rural electrification, commercial industrial applications to solar and wind integration, as well as some specialty applications such as hospitals, telecom industry, spatial economic zones, as well as introduction of grid ancillary services. Now, some of these markets have already started to develop. For example, telecom industry in India, they have a regulatory mandate for reducing diesel consumption in telecom towers, and just in last 1 year, some of the leading Indian telecom operators have purchased more than $350 million worth of advanced energy storage solutions for reducing their dependence on diesel. There are again fuel cell technologies which are getting demonstrated for such applications, but the current leading technology for such application is lithium-ion batteries. But at the same time, the application and opportunities will be open for range of technologies considering the breadth and depth of the applications required. So again, before I get into some high-level opportunities, I would like to focus on 2 real immediate opportunities which are available for companies who are interested in participating in Indian market. These include a first of its kind of pilot project proposed by Power Grid Corporation of India. If you're not aware, Power Grid Corporation of India is the central transmission planning utility in India, which manages all the transmission network in India, and it is amongst the 3 largest power grids anywhere in the world. As well as there are additional projects proposed by Ministry of New and Renewable Energy Resources. So to give you a quick background about PGCIL, the Power Grid Corporation project, Power Grid Corporation is mandated to look at transmission requirements for accommodating all the renewable energy which could be developed in India, considering the very aggressive plan by MNRE. Now you will notice in the map which is shown on the right hand side, there are certain areas, around 6 to 7 key areas which are resource rich for renewable energy. For example, Andhra Pradesh is identified as potentially 20 gigawatt potential for renewable energy. Similarly, Tamil Nadu has almost 54 gigawatt of potential. Even Gujarat has over 34 gigawatt of potential. So there are different pockets in country which are expected to contribute maximum to the integration of renewable energy. but the need of this energy is going to be across the country, and that's where Power Grid Corporation has set an ambitious project called Green Corridors for building the transmission network to support integration of all these renewables over next 5 years. So they have allocated currently almost euros 786 million for implementation of this project, which corresponds to around 32,000 crores in Indian rupees, and out of that already they have earmarked around 261 million euros for anticipated need for energy storage for optimizing this transmission network. So to start off, Power Grid has already earlier this year initiated RFP where they are looking at 3 projects, total projects of around 1.5 megawatt size for exploring ability of energy storage technologies for providing grid frequency regulation as well as load management. So the location of this project is going to be Puducherry, which is close to Chennai on the southern part of India. Puducherry is already a host for some of the smart city efforts underway in India, and that's where PGCIL has already selected Puducherry as the location for the first of its kind of demonstration project for energy storage technologies as well. As I mentioned, looking at total of 1.5 megawatt for this initial demonstration, but since this is a early stage demonstration and PGCIL wants to get as much information about different technologies, they have made this as a part of 3-stage or 3 technology demonstration where each technology is expected to be half megawatt with 250 kilowatt hour of minimum energy delivery capability. Depending on the state of the charge requirement as well as other drivers for the technology, people can size this in a different way. So in terms of the total energy installations, it could be much bigger than 250 kilowatt hour. For example, flow batteries typically are sized for 2 to 4 hours at the minimum, so they could be 1 or 2 megawatt hour in size for the same application. So PGCIL has clearly identified 3 categories. One category is reserved for advanced lead acid technologies, one category is reserved for lithium-ion chemistries, and the third category is open to either alkaline, flow batteries, or sodium-based batteries such as sodium sulfur or sodium nickel chloride. So currently RFP responses are still open. They were originally scheduled to evaluate these responses by October 7th, but because of some of the holidays in India earlier in the October, they are now extended it to 21st October, and the selection is expected to take place by December 2014. And by March 2015, they are expecting some of the initial installations will be completed. Now the reason for the frequency regulation is that as you are aware, frequency regulation is one of the key ancillary services which is required for maintaining the grid frequency at a steady level. Most of the developed countries and in Europe also, the frequency band which is allowed is very tight. It is typically 0.02 hertz around the rated frequency. But in India, the frequency management is currently done under a regulatory mechanism called unscheduled interchange, which tries to manage the grid frequency based on 15-minute average frequency. And that's where on an instantaneous basis you end up seeing quite wide frequency deviations, such as you are seeing on the bottom chart, which represents sort of a one typical day of data, where frequency deviations have happened from 49.6 to almost 50.4 hertz. And this is not the worst. We have over 2 years of data which we have compiled for 4-second frequency interval, where we have noticed frequency deviations almost from 49 hertz to greater than 51 hertz. So this is definitely an issue which needs to be addressed, and currently Central Electricity Regulatory Commission, which is equivalent to Federal Energy Regulatory Commission in US, is currently working on a policy paper for introduction of ancillary services in India. So this project, although is a very small with just 3 half megawatt project installations, could pave a pathway for integration of large-scale energy storage for such application in India. Now there is a precedence in how this should be done. US over last 2-3 years has changed their ancillary service markets to a mechanism called pay for performance. The schematics in this or the chart in this slide shows how a conventional generator, which could be a coal or which could be a thermal plant, responds to same control signal, which is represented by the red line, and the green curve, which is green area, which is sort of towards the center of the chart, and then the blue line and the light blue curve represents the amount of energy which could be charged or discharged by energy storage solutions which are able to respond to this in a very fast manner. So it was found through some of the initial simulations that the same 1 megawatt resource could provide as much as 4 to 5 times more service in terms of balancing the grid as compared to the conventional resources, and that's where the US Federal Energy Regulatory Commission came up with this pay for performance mechanism, where there is a performance payment which is based on the mileage driven by energy storage or any fast resource for providing frequency regulation, and they also take into account for the accuracy and precision for providing this service. And this is right now driving a very strong interest in energy storage deployments in US. Currently there are more than 300 megawatt of projects in late stage planning and early stage of construction in US for deploying various technologies for exactly these applications. So in the Indian context, given the current load of India is around 140 gigawatt, we expect that there is at least a need of 1.4 gigawatt of frequency regulation, and even if you sort of split the total frequency regulation requirement with both conventional and new resources, it will create at least a 350 megawatt of requirement for energy storage technologies within a span of next year or two. And by 2020, we expect that looking at the size of the grid to grow somewhere between 250 to 300 gigawatt, as well as the increased penetration of renewables, this requirement could actually increase to somewhere around 650 to 1150 megawatt. So this could be one of the largest markets for energy storage technologies who can provide the fast regulation or fast response capabilities anywhere in the world. Now, another opportunity which is coming up is RFP, which should be released any day now by Ministry of New and Renewable Energy by Government of India. They have already released the expression of interest 3 months back, and the standing committee, which is constituted by MNRE to look into energy storage adoptions in India, has already approved this pilot project where MNRE is looking at ways for enabling greater renewable integration in India. The central regulators have already tried to introduce wind scheduling, but there the wind operators have found a challenge that because of errors in forecasting, they haven't been able to do the forecasting with the accuracy required by the regulators. This is a chart which shows that the way to read the chart is that the green circle represents 100% accuracy on the forecast, the red circle represents 30% error on the positive side, and the purple circle represents 30% error on the negative side. And this represents, the wiggly lines represent 3 different days in which the forecasting errors you can see at number of times were either above or below the scheduled margin. And the way the regulations were proposed initially was that for some initial period the 30% error margin would be allowed, but over the years, as people gain more experience in forecasting, this band could be narrowed down further. So that has presented significant concerns amongst wind developers who are traditionally relied on just pumping into total amount of energy and getting a fixed price for the energy, but now the potential penalties because of deviation present a significant challenge. And that's where energy storage technologies are expected to play a key role. So MNRE is looking at 4 key applications. One is integration of large-scale wind and solar integration in transmission grid. One project could be for rural microgrids. Then there are 2 projects which are again megawatt scale, where one for microgrids in either commercial, industrial or residential sites. So these are expected to be like 2 to 5 megawatt in size, as well as MNRE is looking at demonstration of standalone energy storage system for say commercial or industrial customer as a demonstration as well. MNRE has made it completely open and completely technology neutral, so there is no barrier for any technologies. Of course, ideally the technologies which are being looked at are say up to 100 kilowatt for the rural microgrid, and for like 1 to 5 megawatt for the other applications. So some technologies may still get eliminated because of this choice, but otherwise MNRE has made it completely technology neutral. Thermal storage for solar is not included because there is a separate dedicated program for those type of demonstrations, but otherwise all other type of technologies are welcome to participate. So this RFP is going to be released sometime this month, and it is expected that the selection process will get completed by February 2015. MNRE will monitor the results of these projects over 3 to 5 year period, and will also use these projects to come up with additional opportunities for integration of storage. And one thing I would like to highlight, that the opportunity is not only limited to these 4 projects, but in principle there is a very strong interest in encouraging all appropriate technologies. So apart from this one particular pilot, it is anticipated that there will be somewhere around 4 to 5 additional projects which may get selected either under the smart city demonstration program or under solar demonstration program. So what the committee has decided is that any projects which are technically qualified will also be recommended to some of these other opportunities which come up in near future. So again, if you have a technology which you want to bring to India, I will encourage you strongly to consider participating in this MNRE program and present your technology to MNRE. Now, apart from this, there are other opportunities such as smart grid deployments. India has already released a smart grid roadmap where they are looking at enabling energy access, integrating greater wind and energy efficiency, and then as well as there is a focus on electric transportation, where under electric mobility mission, Indian government is looking at adding somewhere around 6 million electric vehicles on the road, and for that to happen there is going to be need for also other supporting infrastructure also in terms of the stationary storage and charging infrastructure as well. So there are lots of opportunities where various policy initiatives are coming together, and both Ministry of Power as well as Ministry of New and Renewable Energy is realizing that energy storage is the missing link for achieving a range of goals which these ministries have set up in their target. One of the other challenge and opportunity for energy storage is the concepts for microgrids. Again, as we have seen it around the world, that whatever supply side redundancy you may build in, the electric grids are subject to potential outages because of natural disasters. In US in 2012, Hurricane Sandy demonstrated this, where even the New York City, which has otherwise a very strong local energy capacity build-up, was left completely dark for weeks at a stretch because of the damages caused because of Hurricane Sandy. And same thing has happened in India, where in 2013 cyclone fell in, and earlier this week cyclone Hudhud has demonstrated the sort of limitations of electricity grids to cope up with such natural disasters. And that's where again microgrids could provide tremendous solutions, where using local solar as well as other distributed resources backed up with energy storage, people can at least ensure that all the critical infrastructure services are continuing, and hospitals, telecoms, some services are maintained even in case of such disasters. Now, apart from this, there are also opportunities purely on the commercial level, where, as you know, that India has plans to build more than 100 smart cities. Now, these could be for millions of people, but while we are waiting for these large smart cities to be built, there are actually more than 300 ultra-modern townships getting built purely through private resources at this moment. Just actually out from my window here in office in Pune, I can see actually 3 of such townships, and this township is the one which is closest to our office here, where they have a complete special economic zone with companies such as Accenture, TCS, and leading IT companies present, with almost 30, 25-story skyscraper buildings. But typically such townships get developed in areas where land is cheap. So these are built slightly on the outskirts of the main cities, where typically the electric grid could be weaker. So such townships are getting built with lots of green features, but then ultimately for electric reliability, they depend on diesel generators for backup. And once the township starts operational, the occupants have to pay for the high charges for this diesel consumption, and that's where there is now a very strong interest in exploring use of energy storage technologies at township level or as a community resource, where people don't have to put in individual UPS systems at homes, or people can avoid dependence on diesel generator in case of power outages. There are also opportunities for integrating storage as part of various energy efficiency and demand side management initiatives. Particularly, I would like to highlight in this area opportunities for thermal storage, because lots of time when you talk about energy storage, people only think about electrochemical batteries. But we as India Energy Storage Alliance have a completely technology neutral approach, and we also believe that technologies such as thermal storage are going to be very essential part of solution mix in Indian context, because what is happening right now for most of the utilities in India is that the middle class in India is growing at a much faster rate, and something which has happened maybe in Europe or US in 70s, where people started switching from just using ceiling fans to using air conditioner. The same transformation is happening in India right now, and that is causing a problem for utilities, where the peak load goes up very much, and the nighttime demand is not rising as fast. So in terms of doing the integrated resource planning, thermal energy storage technologies could provide a perfect solution for a country like India, where the transmission and distribution networks may be already stretched thin to try to meet the peak demand requirements during the day. The only way right now utilities are managing this is by using load shedding, that is mandatory load curtailments for customers directly at the feeder level, but by incorporating better control technologies, integrating building automation, demand response technologies along with thermal storage, we can definitely provide much more better choice and alternative for consumers. I already touched base on this in terms of the electric mobility mission. India is one of the fastest markets for vehicles. India has become a global manufacturing hub for small electric vehicles, and there is a very strong interest in trying to modernize the public transportation infrastructure, where maybe a decade back there was a move towards moving the public bus system from diesel to CNG or natural gas, but now again there is a similar opportunity available, whereby integrating electric vehicles in the supply mix, India can significantly reduce the dependence on oil, because that is the single most risk India has in terms of the economic stability of the country and current account deficit, is the heavy dependence on imported oil and the fluctuating prices of oil, right from say $78 right now to up to like $150, which we have seen over the last couple of years. But now again, I think we are getting towards end of the allocated time, but I'd like to just mention that the opportunities which I've highlighted are just tip of the iceberg. As I mentioned in my opening remarks, telecom sector presents a huge opportunity. The $350 million worth of lithium-ion battery purchases which have happened in last 1 year, they represent only maybe around 20% or less than that of the current market which is open. There are still at least 500,000 plus more telecom towers which are looking for solutions, and under the regulatory authority of Telecom Regulatory Authority of India, there is already a legal framework set where these telecom operators have to reduce their diesel consumption over next 5 years. Similarly, these sort of kilowatt level solutions could also be very much applicable for bank ATMs, because again, as India is moving towards providing access to the financial inclusion for all, you may have heard in news that earlier this year the new government has set a goal for opening up bank accounts for every citizen in India, and again, bank ATM machines are becoming one critical factor for making this financial availability, and in particularly remote areas or even in second or third tier cities, these ATM machines are going to require power backup solutions with 3 to 10 kilowatt type backup systems would be a perfect solution. India is also looking at adopting solar for different applications such as agricultural water pumping, where right now there are more than 9 million diesel power water pumps in operation, and also number of water pumps are dependent on grid power, which is very erratic, particularly for agricultural sector, because of political reasons. In lots of states, agricultural power is supplied at free of cost, but at the same time the power is only made available when there is excess power available on the grid. So people are definitely looking for solutions where they can have more distributed and power which is in control of farmers, and that's where solar powered water pumps will drive the adoption. But again, people may ask that, okay, you can do huge solar power pumps and you can just store the water in a tank. Why do you need energy storage for this? And reason for that is that once you start going beyond certain, say, millions of water pumps for solar adoption, when you have all these water pumps operating at the same time of the day, because based on the solar availability, there may be challenges in terms of managing the groundwater levels. We have already seen in parts of India where in summer months when the water level goes down, actually people cannot pump water more than 1 hour at a stretch. They may have to do it where 1 hour they pump the water, then wait for 4 hours for the groundwater to replenish, and then again pump. So if you are only relying on solar water pumps, then you are going to have limitation in terms of how much water pumping is achieved during the day, whereas if energy storage is integrated, there will be a lot more flexibility for also managing the groundwater resources. I've already talked about the energy access challenge. There are currently almost 300 million people in India who do not have access to any energy at all, and so again, this all presents a huge opportunity for energy storage technologies. And as part of our analysis, we have looked at different states, and these opportunities are present across India. And again, if anyone has more interest, we have a complete detailed reports available which provide insights into regional opportunities for energy storage. So with this, I'd just like to take 2 minutes to brief you quickly about India Energy Storage Alliance. As I mentioned at the start, IESA was launched in 2012 by Customized Energy Solutions to help technology and system integration companies to help understand India market opportunities. In 2013, we also expanded the network as a knowledge partner network with also a aim of educating key users of energy storage. So as you see that Power Grid Corporation, which has launched the first pilot projects in India, is part of the network, and we have been working with them over the last 1 year to help them in design their program. But again, you'll notice a good mix of both technology providers as well as potential users as part of the network. We are also, apart from directly working with companies. We are helping drive the policy framework for storage. I'm part of the National Task Force for Renewable Integration for Ministry of Power, part of the Standing Committee on Energy Storage for Renewable Energy, driving some of the initiatives at the state level such as the Maharashtra Electricity Regulatory Commission, and also working closely with various renewable and other industry associations to make sure that we are not replicating efforts and we are able to bring benefit and develop an ecosystem for all of you to come to India in as fast manner as possible. If you need more information, you are welcome to visit our website, which is www.indiaesa.info. There is lots of free information available on site, but if you are a member, then you also get access to additional member-only resources, which also include a section where we regularly update RFPs and tenders available related to the energy storage technologies. To help you understand the market, we also do periodic reports, and again these reports are also available for purchase to non-members, but if you are a member, then you get special prices for purchasing these reports as well. And last but not the least, I'd love to host all of you here in India in December. We are organizing the second international conference and exhibition on energy storage and microgrids in India in New Delhi at Kempinski Ambience. We are getting tremendous response from all corners of the industry as well as users and policymakers. We are going to have a special policymaker only workshop in collaboration with IRENA, where we are expecting policymakers from over 15 countries in Asia Pacific region to come in and participate and learn from each other's experience on how energy storage can help accelerate renewable deployment in countries such as Philippines, Indonesia, Sri Lanka, Bangladesh, Australia, India, Japan. So again, please, if you are interested in this area, please use this opportunity to join us. And as a member of EBTC, you are entitled for a special 20% discount till 1st of November. So again, I'll encourage you to join us, and there will also be exhibition opportunities available. You can either coordinate through EBTC or approach us. We are looking at possibly hosting a special European pavilion if there is enough interest from all of you. So to conclude, again, I'd like to reiterate that India presents a huge market for advanced energy storage and microgrid solutions. Already, India spends around 2.7 billion euros each year on lead-acid batteries. And again, some of the opportunities which I have talked are not only dependent on the current applications, but we are looking at actually growing the market and addressing new opportunities. So the market size is much, much bigger than what is addressed by current lead-acid battery market. But one thing I would also like to request is that don't consider India only as a market. India also presents an excellent opportunity for collaboration for R&D and manufacturing, and particularly exporting to Asia Pacific as well as African region. And the new government of India has specially launched this Make in India program, where they are looking for providing incentives and enabling environment for making such manufacturing take place in India. So again, if you are a technology developer who has an interesting technology and are looking for partners, will be more than happy along with EBTC to help you in develop such partnerships and develop a manufacturing base in India. With that, I'd like to hand it back to Joel, and just again, if you have any questions about either EBTC or about IESA, feel free to reach to Joel and me, and both EBTC and IESA together are looking to provide you a gateway for entering this exciting Indian market. And again, we understand that there are challenges in entering India market, but that's where using our collective strengths, we can be a valuable partner for making it as painless as possible for you. So thank you. Joel, do you want to take over?
Thank you, Rahul, for that. Yes. Thank you, Rahul, for that very informative presentation filled with statistics and also very focused on the opportunities that lie in India. Right now, let us open this for the participants that have participated on this webinar and have a question and answer panel. So I would urge you and all the participants, if you have any questions, to please go ahead now and post your questions on the right-hand corner of the webinar's platform, so that we can take your questions now. Alternately, you can even, there's a small icon saying raise your hands, then we can unmute you so that you can ask the question directly. If you are not able to post the question, you can raise your hand. There will be a little icon on your dashboard. Okay, we have a question that is coming in from Katarisan Rajagopal. Is it possible for us to share the presentation through email? Yes, it is possible for us to share this presentation to you, Katarisan, via email. There will also be a video available, a video link of the entire webinar that can be sent to you, so you will get the video link so you don't miss out on the presentation made by the guest speaker as well. If there are any questions on the upcoming event organized by IESA, you may please post your questions now.
Joel, while people are putting their questions together, maybe I can just quickly explain what we have planned for the event, if that's okay.
Yeah, go ahead.
So it's going to be a 3-day event where the first day of the event on 3rd of December is dedicated for workshops. We have a energy storage 101 workshop to educate audience members about advances in various technologies. Then in the afternoon we have 2 parallel sessions. One session open for all the audience, which will focus on 2 mini workshops, one on solar and microgrid opportunities, where we are partnered with TERI, the Energy and Resources Institute, for hosting this workshop. And then we are also hosting another workshop on power quality issues in India and how energy storage technologies could present a solution. So that workshop is jointly organized with APQI, Asia Power Quality Initiative, Copper Alliance, and IESA. And then in parallel to these 2 workshops, we'll have a invitation-only workshop for key policymakers jointly organized with IRENA, the International Renewable Energy Network, where we'll be focusing on role of energy storage for renewable integration. Then on the second day of the event, which is 4th of December, we are dedicating the day for policy level discussions in the first half of the day, where we are expecting the Energy Minister of India, Mr. Piyush Goyal, to inaugurate the workshop, and also have senior level bureaucrats from both MNRE and Ministry of Power present to share their views about how energy storage technologies could be integrated in India. Then in the afternoon, we'll have an international panel to talk about energy storage adoption experiences around the globe. And after that, we are going to focus on case studies as well as a panel discussion on renewable integration, along with a special panel on Make in India, where we are expecting Mr. Amitabh Kant, who is heading the Make in India initiative for Government of India, will also join us for that, along with some of the prominent industry leaders who have already set up manufacturing in India and a couple of new entrants. Then in the evening, we'll have a networking reception open for all, which would be a good opportunity for people to interact with policymakers and key decision makers or customers. And on the final day, we are going to focus on smart grids, smart cities in the morning, along with electric vehicles. Then in the afternoon, we are going to focus on commercial industrial application and rural electrification. And in the end of the day, we are going to have 2 sessions, one on financing, and we will run a 1-hour competition called Innovation Pitch Competition, where we will be, there will be around 4 to 5 new startup companies who will present their ideas to a panel of 5 private equity or venture capitalists who are looking at investing into new companies. That's a general format for the 3-day event. And then for a select audience, we are basically also making this event as a part of a special week-long technology tour, where there will be 2 additional days at the start of the week. One will be for site visits for some microgrids and energy storage installations in India, and one will be some additional select roundtable discussions with key policymakers and potential customers, as well as people who choose to participate in the entire week-long program can also get additional one-on-one networking opportunities based on the requirement which they can specify ahead of time. So again, if you're interested, please drop me an email either through EBTC or directly, and we'll be happy to provide you more details.
Rahul, we have a question. We have a question from Kativisan Rajagopal, who's from SecuTech Automation. The question is, with respect to thermal storage, what kind of incentives provided by government to encourage this technology?
Sure. That's a very appropriate question, and right now I would say that state of Maharashtra is at the leading in this. So Maharashtra Electricity Regulatory Commission has already gone ahead with introduction of time of use tariffs, which provide incentives for people to shift their load to off-peak load. But apart from that, there is a special incentive for thermal energy storage, especially in Mumbai, where they have introduced additional incentive for thermal energy storage technologies for shifting such load to off-peak period. Apart from that, thermal energy storage technologies are also eligible to participate in demand response program that is particularly using the flexibility to shift the load beyond what is done on a day-to-day basis. So these are the 3 current existing mechanisms, but apart from this, on the thermal storage, and again, right now when I said thermal storage, I was focusing more on sort of a ice storage for air conditioning applications, but there are also a very strong focus on thermal storage for applications such as cold storage chains for agricultural applications, as well as thermal storage in terms of the heat storage for 2 areas. One for waste heat recovery. There is a program called PAT, Perform, Achieve and Trade, where Indian government has already identified 8 key energy intensive sectors where they want to improve the specific energy consumption of these utilities, and one easy way to do that is through waste heat recovery and integration of that waste heat into processes, and that's where again thermal storage could be a key player in that area. And the improvements which can be done through such projects could be monetized through this PAT, where basically the companies who are implementing these projects will be eligible for white tax certificates, which could be traded separately in the market. It is just starting, so again right now there is no clear indication in terms of the prices which can be fetched by white certificates, but there is a mechanism for that available.
Thank you. Thanks, Rahul. If there are no more questions, we would conclude this webinar. Rahul, if you could help me shift the slide to the next slide, please.
Sure.
Yeah. So if in case you would like more information on EBTC, please feel free to visit our website. Alternately, if you want the presentation made by Rahul and myself today, you could send us an email at info@ebtc.eu, and we'd be happy to share with you these slides. Alternately, you can also visit the EBTC website where the webinar video will be showcased. And these are our social network areas where you can also get more information on EBTC. With that, I would like to thank all the participants from Europe and India for participating on this webinar. Dr. Rahul Valuvalkar, thank you for your support and for that great presentation. And thank you everyone for today's discussion. Thank you. Bye-bye.
Thank you, Joel and EBTC team, for hosting this. Thank you very much.